Hello everyone, this is Mr. Barely. Today we're going to be going over how to graph a quadratic equation in vertex form when I'm only given the vertex and a point. So just a reminder, this is the same thing that we did in class today. So this is more for your review. I know we have a test on Monday, so I want you to have some kind of resource in case you have questions over the weekend. So just to say, if you're looking for something new, this is not that. Now, to go ahead and get into it, we know that vertex form is equal to a times x minus h squared plus k. We know that h comma k is the value of the vertex, where h is the x value of the vertex, and k is the y value of the vertex. A is a coefficient that's outside of the parentheses, so you should know from your transformations that because it is a coefficient outside of the parentheses, that this is a coefficient that is either going to vertically stretch or vertically compress our quadratic equation. Now, let's go ahead and get into this first example. So it wants me to write the quadratic equation when I'm given the vertex of 5, negative 3 and the point 7, 5. So the first thing I'm going to do is I'm going to come over to my Desmos calculator and I'm going to label those points appropriately. So 5, negative 3 is my vertex, and 7, 5 is my point. So in order to know that I have the right equation, it needs to go through this vertex and go through this point. Now I'm going to begin filling out this formula right here. The only problem is I don't know what my value of a is yet. So for the time being, I'm going to leave it out of the equation. I'm just not going to put it in there. So I'm going to begin filling it out. F of x is equal to, x is a constant, so that is always going to stay there, minus h, and h is 5, because remember 5 is that x value in, is the x value in my vertex. So x minus 5, don't forget to square it, otherwise you're going to end up with a straight line. And then my k value is negative 3, so I'm going to tack that k value right there at the end. Now, immediately I can see that my parabola is going through my vertex, but it's not going through the point. So I'm going to need to change, I'm going to need to find the a value that makes this parabola go through this point. So I'm going to make an educated guess here. Now, as I said earlier, a is a value that is either going to vertically expand or vertically compress your parabola. Now, I know that if I vertically expand a parabola, it's going to get skinnier. If you imagine that ball of Play-Doh in your hand and you stretch it vertically, it's going to get taller, but it's also going to get skinnier, right? So I already know that this needs to be a vertical expansion. So I'm going to begin this process by inputting the first whole number that is going to be a vertical expansion. So that first whole number is going to be 2. And just like that, I have my point. It goes through the vertex, it goes through the point, so I know that the correct equation in vertex form is f of x equals 2 times x minus 5 squared minus 3. Now, not every single time is my a value going to be a vertical expansion. Sometimes I'm going to need to do a vertical compression. So let's take a look at what that might look like. So I'm going to go down here to example number 2. So example number 2 has a vertex at 2, 1. So I'm going to change my points here. This is going to be 2, 1, and it's still my vertex. And then my point changes to negative 4, 10. Now, I'm going to begin filling out my formula here. Once again, I don't know what my value of a is, so I'm going to leave it out. So it's going to be x minus h. In this case, h is 2 because h is equal to that x value of the vertex. Don't forget to square it. And then I'm going to add on my k value, which is 1 in this example. Now I can see that my parabola is going through my vertex, so I haven't made any mistakes so far, but I need to find an a value that is going to cause my parabola to go through this point. Now I can see that this point is far outside of my parabola. So once again, imagine that Play-Doh. If I vertically compress it, it's going to get shorter, right? But it's also going to squish out to the sides and get wider. So I know that I need to be putting in values that are going to vertically compress. So let's start with the most basic one. Let's start with 1/2. I got closer, but I didn't quite get there. So I need to find smaller and smaller fractions. I need to compress it more and more. So let's go to 1/3. I got closer, but I'm still not quite there. And then finally, let's go to 1/4. It's now going through my vertex and my point, so I can see that this is my correct equation in vertex form. I hope you find this helpful. Remember to study hard for this test. I'll see y'all on Monday.